Hey guys, Mr. Bowman here. Today's learning objective is on the paint on the left, and we are learning to determine the equation of given trig graphs. And what we're going to do is we're going to start off with a cos graph, and I've written down the cos formula on the left there. Before we get into the graph on the right, let's have a look and recap what the A, B, C, and D in our trig graph actually meant. So the easiest one to remember was D, and D is any movement up or down from where you expect. And just a reminder, we would expect a regular trig graph to be, the middle needs to be 0. If the middle has been moved up or down, you'll be able to figure that out. C, that is the movement either right or left. And don't forget that's the negative value. So if it's moved across to positive 90 degrees, that means it's negative 90 for C, sorry. C relates to the period or the frequency. So in a regular curve, a full period or full cycle is 360 degrees. You need to figure out how many cycles fit in that 360 degree period. It might be a half, might be a third, might be 8. Who knows? And then A was the amplitude, and that related to the height of the frequency. So amplitude, I'm just going to call that height, and that normally should be 1 from the middle, but you'll be able to look at your graph. If it's slightly different, you'll be able to see. So the first step that I want us to look at for our graph, the easiest one to figure out is always that D value. So let's have a look. So D here, that is going to be equal to, so we need to find the middle of our graph, and the middle of our graph looks to be kind of along here by -1, and that means it's been moved down 1. So it's been moved down 1 from 0 to its new position at -1. So let's write that down, -1. C is often the next easiest one to figure out. That's the movement left or right. And in our graph, we were told it's a cos graph. And our cos graph should start at 0, just over there where my pen is. And what's happened, it's either been moved left by the looks of it 30 degrees, or alternatively, it's actually could have been moved right to 90 degrees. So you're allowed to use either of those numbers, but let's always try to remember, let's try to deal with the standard range between 0 and 360 degrees. So in my view, the better answer would have been the move to the right by 90 degrees. But if you did right the other way, that would also be correct as well. So that means in our case, the C value, that could be -90 or +30, depending on which way you went. Because that graph, it's symmetrical, could go either way. All right, the B, we'll go to A, the height or the amplitude. So we can see this amplitude is meant to be 1. So it's meant to have a height of 1, but here it's clearly got a height of 2. So that means it's been multiplied by 2. So that means our A value, well, that's going to be 2. And the last one to figure out is B. B relates to how many cycles fit within a 360 degree range. So what I'm going to do is I'm going to start off here at 90 degrees, and I'm going to go all the way to 450, which is 360 extra, which is this dot here. So how many full cycles fit in that 360 degree period? So let's have a look. So we got 1 full cycle, 2 full cycles, and then a 3rd full cycle. So that means we have 3 cycles. That means that A or that B value is going to be 3. And what we can do from that, we can pull together all of that to get our final formulas. I'm going to write both formulas to do with the -90 and the +30, because either of them are correct. So y is equal to 2 lots of cos, and then small bracket 3 square bracket x minus 90 minus 1. So that could be one version of the answer. And I'll point out a little bit, but there's actually many answers in Trig for these. So y is equal to the next one, and we're now going to use it with the plus 30 cos small bracket 3 square bracket x plus 30 minus 1. So either of those answers would be correct, but I just want to note we typically like to deal with the portion of the graph between 0 and 360 degrees. So I'm thinking the negative 90 would be better. But I also want to note, you might have think that starting point might have moved all the way over here to 210. So that actually meant another variation of the answer could have been cos 3x minus 210 minus 1. And you'll find there's actually many variations. It could have been moved to that 330, could have been moved to that 450, could have been moved to that 150. So all of those are potential answers, but we normally focus on the answers within the range of 0 to 360 degrees. So hopefully that makes sense. What I'm going to do, I am going to pause the video and I'm going to get into a few or a sine example, and then we'll get into some questions for today. Okay, guys, we are back and we're looking at our sine example now. The graph we're trying to find the formula for is actually this blue graph. But the thing I want to note is what I find quite useful is I sometimes draw or sketch very roughly the basic graph, and I've done that in green. So that's sine x, and I know that has a full cycle between 0 and 360 degrees, and it starts at 0. So let's have a look at this sine graph. The first one I normally start off with is the height. What's happened with the height? Has it been moved up? Has it been moved down? So the height should be here at 0, 0. So the line of symmetry, so to speak, should be there. And if we have a look at this graph, well, the peak appears to be at, what's that, 3.5? And the trough appears to be at 2.5. So that means that middle bit in the middle, which is 3, appears to be the height. So that means our graph has been moved up 3 units. So for that, d is going to be equal to 3. So let's have a look at the sine or the plus c, how much it's been moved left or right now. So again, we expect our sine graph to be at 0, 0. So we need to think how much has that point been moved across. So we know our new line of symmetry is going to be this 0. So we need to follow, 3. We need to follow 3 until we hit the graph. And that there would be how much it's moved across. And it looks like it's going to be 100. If I can get the exact point. There we go. So 100, 3 that was. So by following that line, we can see, oh yeah, that should be here, but it's actually been shifted to the right to 100 here. Because that's a positive 100, c should be a negative value. So c should equal negative 100. But I do want to note, in theory, you could have followed this line the other way. So you could have said, well, it's been moved all the way over here to 260. That would also be a correct answer. You could also follow it further to say that it's moved up over here to 460. All of those would be correct answers, but we try to focus on the answers that lie within 0 and 360 degrees. So that's why we picked 100, but it could have been the earlier one, could have been the later one as well. The next one I like to work on is A. So A tells us about the amplitude or the height. So we can see our basic trig graph down the bottom. That does have a height of 1. So it should be going up 1. And from our center, which we said was 3, it's only going up and down a half. Up and down 1/2. So that means that A value is actually going to be a fraction 1/2. And that's why it looks a lot flatter or skinnier than it actually is. And the final one is B. We need to figure out what B is as well. And B relates to the cycle of that graph. So if you have a look at the green graph again, so it's a really good reference, that value should have one full cycle at over 360 degrees. But what we need to check is how many cycles it has here. So let's start off at that 100 point there, and let's follow it all the way to 460 degrees, because that's adding 360 degrees to see the cycle. And let's see how many cycles it actually has. So 460, well, that's actually there. So it looks like it's that flat part that we've measured from here to here. That looks like a half cycle. So it's done the up part, but it hasn't done the down part. And if you have a look, the down part here carries on, and it looks like the down part is going to finish just over here at 820 degrees. So it looks like it's actually taken 720 degrees to do that full cycle. So that means we've got half our cycle within 360 degrees. So that means our B value is actually going to be a half. So we've only got the up part of our cycle. So that's going to be a half. So I've got that in there. We can now pull A, B, C, and D together to form our final equation. And I'm not going to be writing alternative equations this time, because we should have learnt to focus on the answers within 360 degrees, or between 0 and 360. So y is going to be equal to 1/2 of sine. Sorry, let's get rid of that to make that look a bit neater. Sine, and then bracket b is also going to be 1/2 x minus 100, because that moved to positive 100. Bigger bracket plus 3. And then just to note, we could have had alternative answers. We did say that could have been that could have been positive 260 or negative 460. But we are focusing on answers within the 2 pi or the 360 degree range. So hopefully you found today's video useful. Let's get through some questions. We're going to focus on sine and cos, but there are some stuff about tan that we're going to learn later on, or next year potentially as well. All right, let's get into some questions.